Hello everyone, today in this video we'll be discussing the part 2 of module 3 of 18CS71. So in this part of the module we have artificial neural networks. Okay, so suppose that you have a hot pan. Okay, there is something boiling in that. Okay, and you unknowingly what you do is you come and touch this pan. At that time what happens, you will be at the same instant of time you will be removing your finger back, right? How does that happen? There are few steps happening in this place. Observe carefully. When you come near this hot pan, bring your finger near this hot pan. At that time what happens is the heat of this pan gets in contact with your finger and your finger's temperature rises. Okay, so when your finger's temperature rises, at that time in the finger there are many sensory neurons. Okay, neurons you can consider that as some messengers. Okay, like for example, whatever the message is sent to this, it will transform it to brain. It is getting the message that the hot temperature is coming. Okay, so what it will do, it will transfer that message to the brain that hot temperature is coming. So what will happen, the brain will check if hot temperature is coming from this location, what should be done. In its database it will check. Okay, means if hot temperature is rising in this place, what has to be done. When it searches all the possible combinations and from all the sensory neurons the messages comes here, and it will search what should be done here, and output comes that remove the finger from here. So for each of these neuron it will be sending the back the message, remove the finger, remove the finger, remove the finger. So this will be acting upon that, and because of that senses our nervous system will pull back the finger. This all happens in a fraction of second. That's what artificial neural networks is based on this same biological motivation. Human brain has what, millions of neurons. Okay, neurons are nothing but the information storing and messengers like transferring the data from one point to another. In biology we have the neurons. In the normal representation like the artificial neural networks, we have the nodes there. Okay, so each the neuron is called as a node. Okay, so what are the properties of neurons, they are given here, you can go through it. Okay, so I'm not going to explain what are the properties, I'll be just explaining what are the important concepts you need to keep in mind from the exam point of view. Okay, what is the theory part you have to do by yourself. So here's the same example. How does the neural network work? All these examples I have just explained here. If you want the content what to write in the exam, you can go through that. Okay, so coming to the neural network representation, see I told you, right, this is a node. In that how many parts are there? Two parts are there. Okay, so the inputs are coming from here. Okay, these are the inputs which are coming from here, and this is the output which you're getting. In between what's happening, let's have a look. This node is divided into two parts. Okay, this is the summation part and this is the function part. If they ask you to draw the node and explain the artificial neural network how it's working, you have to draw this node for compulsory. Okay, so what's happening here? Here the summation is happening. Summation of what? Summation of xiw, x1w1, x2w2, x3w3 till xnwn. Now what is x, what is w? X is nothing but the input. Okay, and input like taken number 5 6 7 8 9 10. Okay, 5 6 7 8 9 10 came from here. W is how much it is relevant. For example, my favorite number is 6. Okay, so I want the final output to be 6 only. So what I will do, many numbers are coming, 5 6 7 8. Okay, let's assume 5 6 7 8 came. I'm just interested in the number 5, all the rest numbers should be deleted. So sorry, I'm just interested in the number 6, all the rest of the numbers should be deleted, but the summation is happening here. So what I need to do, I have to multiply this by some weight. I'll multiply this by 0, I'm not interested in that. I'll multiply this by 1 because I'm interested in that. This I'm not interested, 0, this I'm not interested, 0. So what happens, the weight of this is 0, weight of this is 0, weight of this is 0, this will not be considered. When you add them up all, you'll get the answer as 6 only. Okay, that's what the summation happens here, and the weights corresponds to how much relevant that input is for the given data. So what happens, then the summation answer will be transformed to the function. The function is called as activation function. What it does, if they ask you about the activation function, what it does, just tell that activation function generates the output. We'll see in detail how it actually generates the output. There are some functions like sigmoid and all. We'll be discussing that in the upcoming part of the video, but for now you have to keep in mind that the function, what it will do, it will, activation function will generate the output. So it will generate the output. Y will be called as the output. It is nothing but the summation of f multiplied by this whole summation. What is summation? Xi wi, x7 w1, x2 w2, the whole summation multiplied by f. That's what the y value is, right? This is how you will represent the node in the artificial neural network, and the same thing is given here also. You can go through it. It is the first thing is summation. Weighted sum will be there. It will be sent to activation function, which will generate the output based on the input given. Okay, Next, we have the representation of artificial neural networks. Do you know how the artificial neural networks are represented? You might have seen this in many places, right? There are some layers here and the nodes will be there in between. This is known as the layers, and the input layer is this one, this is the output layer. In between that we have the whatever layer that is called as hidden layers. Okay, so what happens is whatever the input we have received from here, this all input will be transferred here as well as here. This input will be transferred to here, here and here. Actually this will also be transferred here. Okay, so from this one to the hidden layer, how many nodes are there? All it will be transferred from here. Or how many nodes are there? It will all be transferred. Then from here it will be transferred to here and here. From here it will be transferred to here and here. Here also, here and here. So what's actually happening is, for example, if I have 1 here, if I have 0 here. Okay, so what happens if I transfer this to hidden layer? 1 will come here and 0 will come here. Then 0 will come here, 0 will come here. Then this 0 will come here, 1 will come from here. Wherever I transferred from 1, from there on 1 will come. Wherever I transferred from 0, there all 0 will come. Now here I will be having the weights also. Means, for example, if I am just interested in finding out 1, I'll be considering this, I'll be not considering this. So what happens when I don't consider this? Whatever the input I get from here, that will not be considered, and it will be null, null and void. Only the input from here will be considered, and finally the output also, that only I will get. So that was the brief overview of the representation. If they ask how many points you have to write, 3 points are the input layer from which the input is given, hidden layer where the inner calculations happen due to the formulas and the algorithms, and the output layer gives us the final output. This is how the artificial neural network is represented. Now what type of problems can be solved using neural network? That's the second question. Instances which are represented by many attribute valued pairs. Many attribute value means in that they have many attributes. Like for example, if you consider a dog is brown, it is short, it is running fast, it barks loud. So all these attributes have many values, isn't it? So that is what the neural network will find. It will take all the attributes of the dog, and like that many dogs attributes will be taken, and what dog I'm interested in, I'll be making it more weight, and the final output also I'll be getting that only. Okay, that's what the first thing. It is represented by many valued attributes. Okay, the target function output may be discrete valued, real valued, or a vector, or the discrete valued attributes. So it can be a combination of any of the given choices. Like in decision tree, it was just the discrete valued attributes, but here it can be real valued as well as vector valued. The next one is the training example may contain errors. Even if there is error because of the biases and the weights, it will get eliminated. Long training times are acceptable. In neural network, it takes a long amount of time. It's acceptable. If there is a problem in which you are ready to give more time for, you can go for this neural networks. Okay, fast evaluation of the learned function may be required. Okay, fast evaluation may be required in some cases. At that time, you can go with the neural network. The last one is the ability of human to understand the learned target is not important. For example, if I give my machine to calculate some answer, I don't know, I don't care how it calculates, I just want the answer. In that kind of problems, you can go with artificial neural networks. So these are the appropriate problems for the neural networks. 6 are there, you have to write all of them. Okay, moving on, the main concept here is the perceptron in the neural network. Whatever I mentioned that, right, inputs are coming from here and the final output you're getting, this is called as perceptron. And in the upcoming topics we'll be learning multi-layer perceptron also, so listen carefully what a perceptron is in the first place. Perceptron is nothing but it is a basic unit used to build ANN, because the nodes only will be there in the artificial neural network. If the nodes only are not there, will it be called artificial neural network? It will not even called a network itself if the nodes are not there. Okay, it takes real valued input. That's the second point. It takes what input? Real valued input, and calculates the linear combination of these inputs and generates the output. It takes the input, calculates, and generates the output. Simple enough, right? So output can be 1 or -1, or you can set it any accordingly based on the threshold values. And as I told you, we'll be including the weights as well as inputs. For example, if I have inputs x1 x2 till xn, and I want to calculate if the output is 1 or -1, what I have to do, I have to multiply x1 with the weight w1, x2 with the weight w2, xn with the weight wn, add up all of this. If this is more than threshold, if I suppose I give the threshold as 10 and answer I get as 9, is it less than 9, less than 10, or more than 10? It is less than 10, right? So if it is less than 10, you have to output -1. If I got the answer 11, that means more than 10, it means the output is 1. Like that, we'll be calculating these things and deciding what the output is based on these summations. So here's an example. The same thing is given here. The x1, x2, x3 and all coming here. w1, w2 and everything is coming. We are calculating xi, wi, the summation from 0 to n. So all this summation will be calculated after multiplying each x by the respective w value. It is sent to activation function. It will give the output. Okay, so sometimes we need the actual output, so that is represented by O, and the target output is represented by T. Like for example, what output we got, suppose that I got 1.5, that is the output which I got. Target output means suppose that I wanted 2.5, that is what I expected, right? That is known as target output. Okay, these two are the outputs. So what we'll be doing in backpropagation, we'll be discussing later, we'll be just making it closer to this one by adjusting the weights. That's all what we'll be doing. Okay, so we'll get to know more about this when we discuss an example. So if the actual target is equal to the target, weights are fixed, otherwise changed. See, it's pretty common sense. If the actual target I got according to how I expected, suppose that I expected 90 marks, I got 90 marks, do I need to go back to the faculty and tell I want few more marks? No, that's stupidity, right? What I expected, I got it, that's enough for me, so I'll not do anything. Weights are fixed. For example, if I get 70 marks, then obviously I will go and ask the faculty where I have gone wrong. I'll change the weight, means I'll try to change the marks by saying that I have written these points and all, so I'm supposed to get marks and so on. All those things will be done when I am not getting what I am expected to get, right? So that's what happening here also. If you're not getting the output which you're expecting, at that time you will be going and changing the weights which you have represented here. Because of weights only you got one output, right? If you change the weights, you'll get a different output. So by changing weights, if I can get the target output, that's my ideal weights. That's all what is artificial neural network about, training the model to get the actual weights set so that I'll get the actual output. Okay, so that's what we'll be learning in depth. And how to change the weights, that's the second question. Initialize random weights. If it is not according to the target value, what we'll be doing is we'll be using one formula. The formula is wi is equal to wi plus delta wi. Every time we'll be adding a delta wi to change the weight. Now what is delta wi? N into t minus o into xi. What is delta wi? N into t minus o by t minus o into xi. What is xi? The initial input, right? This is what the xi value I have represented here, that you will be multiplying with t minus o. T minus o means target minus obtained value, how much you wanted and how much you got. Subtract them and multiply with the input, and then multiply with n. N is nothing but the learning rate. If you make learning rate as more, at that time you will be getting the answer faster, but it will not be that accurate. If you make the learning rate as slow, you'll be getting the answer slowly, but the answer will be more accurate. Okay, so that's, you have to set according to the context given. Okay, so let's move on to the algorithm part. The perceptron training rule has an algorithm. So first we'll be initializing wi is the initial value, which will be any small random value, and you have to repeat until all the values are fixed, means all the values which I have selected that are actually giving me the output. If they are not giving me output, I'll again come and change. Okay, so weight is the main thing which decides what output I'll be getting. For each training instance x comma tx belonging to the whole set x, means this one, the whole training set x, for each of these input I'll be considering one by one, first x1 then x2 and so on. Then what I'll be doing, compute the real output ox, means activation summation w comma x. After doing the summation and activation function, one output I'll be getting. If the target output tx is not equal to ox, the actual output which I got, then for each wi what I have to do, wi is equal to this formula. Again I'll be applying, and again I'll be checking. If I'm not getting, again I'll be applying and checking until I get all the weights in close to the tx, not close, actually equal to the tx. Okay, so even if I am not able to get actual value to tx, after some point of time it will come out based on some condition. If 1000 iterations happen, it should come out even if we did not get the value. Okay, so that's how the algorithm for the perceptron training rule. If we train one perceptron in this way, we can train all the perceptron also in that way, and the whole network will work fine. Okay, so that's what and finally what we'll be returning, the weights we are returning. Why? Because the weight value only we had set, right? For that only the whole algorithm is working, right? Common sense, we'll be returning w only at the end. So that was about the perceptrons algorithm, and it has three applications. We are designing some boolean functions. This explicit question has been asked. Design the AND gate, OR gate and XOR gate using the perceptrons. So listen carefully how to do this one. XOR gate is a bit different one. The linear values cannot be applied here. That reason is also asked in exam, so listen carefully to what I tell. So how do you design the AND gate? First tell me what is AND gate. AND gate means what? Both the input should be 1, then only I'll be getting the output 1. Rest all will be 0. right? If both the inputs are 1, then only I'll be getting 1, rest all the outputs are 0. Okay, that's what the and meaning is, right? So this is the input which I'm getting here, and there are some weights assigned here, and I'm doing the calculation function, and the summation function is getting done, and when I get the output, it should be corresponding to this one. For example, if I give the input 0 0, I should get the final output also 0. If I give 0 1, I should get 0. If I give 1 0, I should get 0. If I give both 1 1, then only I should get as 1. This should be designed so that for all of these A and B inputs, if I give in the respective order, I should get the answers in this respective order. So let's see how to do that. Initially, for that, what we'll be doing is we'll be setting some weight initially. Okay, initial weight what I'm considering is 1.2 and 0.6. Okay, and the threshold is 1 and the learning rate is 0.5. All you have to care about is just the weights now. In this weights, W1 and W2. For W1 I should multiply A, for W2 I should multiply B, right? So when I multiply A and W1, add it with B and W2, means find out this multiplication answer, find out this multiplication answer, and add it up. If I am getting the answer more than 1, then I will output as 1. If I am getting the answer less than 1, I'll output as 0. This is what I have defined. Threshold 1 means whatever answer I get, if it is more than this threshold value, the output should be 1. If it is less than the threshold value, the output should be 0. Okay, so that's what it is written here. Okay, that's all what we'll be doing. First we'll be multiplying A with W1, B with W2, and then we'll be seeing if what answer I get. If it is less than 1, output will be 0. If it is more than 1, output will be 1. Whatever answer I get here after this calculation, it should correspond to this one. Same answer should be there. If it is not, I'll go back and correct it. So let's have a look in the first one. A is 0 and B is 0, and the target I should get as 0. Why? Because when A is 0 and B is 0, I expect the answer to be 0, right? So let's see how let's multiply and see. WIXI 0 into 1.2, this is A value, this is W1 value, plus 0 into 0.6. 0.6 is the W2 value and this is the B value. When I multiply it, I'm getting the answer 0. Is it greater than or less than threshold? It is not greater than threshold. So what should be my output? It should be 0 only. That I have set it like that. If I get it less than threshold, my output should be 0, else it will be 1. Okay, so the output is 0 and it is matching with the expected output, so I'll not do anything. This is pass. Test case is pass for 0 0. Now let's check for 0 1. 0 1 means what? In 0 1 also I should get the answer final as 0, right? So here what I'll be doing, I'll be multiplying this A value with W1 and B value with W2, and I'll get the answer 0.6. Is it less than 1 or greater than 1? It is less than 1, right? So the output will be 0. It's matching with the target output, which is expected to be 0 only. So I have passed the case. Third one, 1.2 into 1 plus what is B? It is means what is W2? It is 0.6 and it is 0 here into 0. What will be my answer? It will be 1.2. Now you tell me 1.2 is greater than threshold or less than threshold? Greater than threshold. What will be my output in this case? 1. But what do I expect? I expect it to be 0, but I am getting the answer 1. So what I have to do? I have to alter this weights. Because of this weights only I am getting this answer 1.2. If I alter this weights in somehow, I will be getting the answer less than this. That's also possible, right? For example, if I make it as 0.6 only, what I'll get? 0.6 into 1, 0.6, 0.6 into 0, 0. 0.6 plus 0 is 0.6 only. So 0.6 is less than 1, the threshold value. The final output in that case I'll get as 0 only, right? So I'll get the correct output what I'm expecting by just changing this weight. So that's all we'll be doing here. That how to tell the machine to do that. That's what we'll be learning here. Okay, when we see here, the output which I got is 1.2, so the final output I'm getting as 1 because it is greater than threshold. It is not matching. When it is not matching, I have to apply this formula. Okay, what is the formula I have to apply? I have to apply Wi plus n into t minus o xi. This is the same formula which I mentioned in the top also. See, this is the same formula which I mentioned here. Whenever I get the value which is not equivalent to the target value, what I have to do is I have to add delta wi. Delta wi is nothing but n tx minus ox xi. Okay, that's all I'll be writing here. N is the learning rate. This is the wi value. Okay, that I will be adding it with this one. I've just done in one step only. So n is the learning rate that we have taken as 0.5 initially. See here, the learning rate I have taken as 0.5. You can take it any value here. So that's all. We'll be multiplying it with t minus o. T minus o is target value is 0. The actual output I'm getting as 1. See here, the target what I expected to get as 0, but because of 1.2, what answer I got? The actual output 1. So that's what t and o, 0 minus 1. Okay, and xi is initial value. What is the input value I have given? In this input value, For the w1 the input value is 0, for the w2 the input value is 1. We are considering this one, right? So this for the w1 the output is 1, for the w2 the output input is 0. So once we will consider for w1, here we will take the a value and here we will take the b value. What is the a value? A value is 1, right? B value is 0. So once we have done this calculation part, then we will be getting two values here, okay? And wi and these two values are the initial weights. Initial weights in this case, how much I took? 1.6 and 0.6, right? 1.6 1.2 and 0.6, that's nothing but whatever the weights I have taken, w1 and w2 initially. That's all we will be substituting here and finding out the new weights. Whenever we found out the new weights, again we have to do from the starting. We have to check if it passes 0 0 0 1 1 0 1 1 from the starting, what we will be doing. Okay, so the new values, what weight I have got, I will be writing it here, 0.7 and 0.6, and threshold is remains same, learning rate also remains same. Again I'll be doing the same thing, multiply this and this by a and b, add it up. If it is value is less than 1, the actual output is 0. If the value is more than 1, the actual output is 1. Based on that, I'll compare with the target of that respective test case. If it matches, it's okay. If it does not, we'll be again going back and applying the formula, changing the weight values. Again I'll be checking it. Like that will happen until I get the correct target outputs. So in this case I'll be getting the target output correct. Why? Because common sense. See here, 0.7 0.6, okay, 0.7 0.6. Let's see from the table itself. 0.7 0.6, put it above 0.7 0.6. Now you tell me, multiply this both value and tell me, add it up and tell me the answer. 0 only, right? And multiply this one with this one and this one with this one, add it up and tell me answer. That is 0.6. That is less than 1 means output will be 0. Add multiply this one and add it up and tell me the answer. You will get as 0.7. That is less than 1 threshold value, so the output will be 0 only. Again add it up, means multiply these both and tell me the answer. It will be 1.3. 1.3 is greater than the threshold value, which is 1, so the output I am getting, I'll be getting is 1. That is corresponding with the output which is given here, right? So in that case I'll be telling this has passed all the test cases, so my final weight values I have selected as the winners. 0.7 and 0.6 is for the OR function. Okay, so that's all. You can go through this one for more information. Final what values you get, that's your final answer. Okay, and this was for the AND operator. Like that only we'll be doing for the OR gate also. Here just you'll be changing these values. In OR, what happens when it's 0 0, you'll be writing 0. When it's 0 1, you'll be writing 1. When it's 1 0, you'll be writing 1. When it's 1 1, you'll be obviously writing 1 only. So based on that, we'll be doing for each test cases. Initially we'll take the weights as 0.6 0.6 and we'll be checking these values. Multiply this, add it up. If it is less than 1, output as 0. If it is more than 1, output it as 1. Based on that, you will be checking it again here for each test case. Whenever it does not match, apply the same formula, n into t minus o into xi for each w value. Alter the w values for each of these. Again check from the starting test cases whether it passes. If it passes all the test cases, these are the final winners of the w1 w2 values. All that has changed from the previous question. This question is just this table values here. In AND it was 0 0 0 1, here it is 0 1 1 1. Like that only you can do it. I hope so. You can easily solve this one. You can go through it for more information. OR gate is also same. I'm not stitching more things because it will make the video more longer. If you have any doubt, ping me on Instagram. My ID is underscore AFUU. Okay, so I'll not be explaining about the OR. I'll be explaining about the XOR function. Why? Because here some variation is there. Okay, the question paper question I can explicitly tell you what has been asked in the previous question is, why is that a single layer perceptron cannot be used to represent XOR function? In this all we are using a single layer function, right? Just one hidden layer is there, we are just getting the final answer, but we cannot do that with XOR function. Why is that not possible? For understanding that, we need to know consider the truth table for XOR function. See here in the truth table of XOR function, what all you can find, how many rows are there? 4 rows are there, right? And this is x1 and this is x2 and this is the output value. In XOR function, if both are same, at that time my output will be 0. In the rest cases my output will be 1. This much you know, right? Now see here, if I plot this in a graph, okay, if I plot this in a graph, this is my x1 values, this is my x2 values, okay, and whatever I have represented here, my output will be 0 and 1 based on that. Okay, so whenever I have both as 0, x1 and x2 both are 0, I am putting a box. Box means what? 0. Circle means what? 1. Okay, if I am getting x1 as 0 but x2 as 1, at that time my answer will be 1, so I have represented by a circle. Here also I am getting 1 0 and 1 1. Here I am getting both as 1, so I have represented it as a box, which is nothing but 0. Okay, so in this case you cannot separate it linearly. For example, if you make a line like this, okay, linear separation means what? By using a single line you have to separate all the circles in one domain and all the squares in one domain. No matter how points you make, you will never get a clear separation where one side of this is just circles, one side of this is just squares. Okay, you cannot get that. Why? Because it's in the different four different directions, right? Completely opposite directions. We cannot separate it using a single line. For that we need to get some function like this. Okay, some function like this, and this will be like all the things present here will be the boxes and all the things present here will be the circle. Okay, so this is what the problem is. That's why we will not be able to represent it using a single perceptron. We'll be doing the two steps and then we'll be representing it. Okay, so what will be the two steps is that, see here, x1 x2 bar. In if you remember the XOR formula, what does the XOR formula mean? XOR formula is represented as x1 x2. Okay, if you see this using the truth table, okay, actually let's do it and derive. Okay, see here, whenever we want an answer, at that time we'll be just considering the truth values. So here what is it? Is 0, so I'll write as x1 bar. Okay, here it is 1, so I'll be writing x2, plus here it is 1, I'll be writing x1, here it is 0, I'll be writing x2 bar. So this is what the answer I got for the truth values. So representing the XOR will be in this form: x1 bar x2 plus x2 bar x1. Okay, so this I know, hope so you know from the previous semesters. Anyways, this is how we will be representing it. First we'll be finding out this answer by using the AND gates, and then we'll be adding it up, which is using the OR gate. Two steps are there: first AND gate operation, then we'll be adding up the answers using the OR gate. Okay, so Z1 will be representing this one, Z2 will be representing this one. Final answer Y will be Z1 or Z2. The three functions are here. So let's do that. The final figure will look as follows. In the previous one you just had like this direct answer, but here we should include one hidden layer also. Why? Because it is not possible in a single iteration. Okay, first x1 and x2 will be here. You will be calculating z1 and we'll be calculating z2. What is z1 and z2? Z1 is x1 bar x2, sorry, x1 x2 bar. Z2 is x1 bar x2. After we have done that, from the Z we will be doing the OR operation. In between this we are doing the OR operation. Here we are doing the AND operation. Okay, after we have done that, we will be getting the final answer. So let's do one step at a time. First let's consider this one, x1 x2. Okay, first function is z1 is equal to x1 x2 bar. So x1 x2 bar, if I draw the truth table, I'll write the values here for x1 x2, all the values when I've written here, and if I calculate the z1 by substituting each of these values here, what I get is 0 0 1 0. In one case only I'm getting as 1, rest of the case I should get as 0. So what is my threshold value? If I am getting the y answer greater than some theta value, I have not defined it. If I get it more than theta value, my final output should be 1. If I get it less than theta value, I should get the answer as 0. So the theta value is nothing but 0 only. If I get some answer which is greater than or equal to 0, my final output should be 1. If I am getting a negative value, my answer should be 0. Okay, so let's consider the first part. In the first part I have x1 x2, both are going to what? Z1, with the weights w11 and w21. Okay, so assume that the initial weights we are considering it as 1, both w11 and w21, both of these weights we are considering it as 1 only. Okay, you can take it any value. For simplicity we have considered it as 1 only, and threshold value is also 1. Sorry, the threshold value what I mentioned here is 0. Sorry, it's not 0, we are considering it as 1. Okay, so whatever answer I get, if it is more than or equal to 1, it will be 1, output will be 1. If it is less than 1, the output will be 0. Okay, so let's have a look how it happens. First x1 and x2 values I'm inserting it here. Wij into xj, that is nothing but w1 into x1 into w11 plus x2 into w12. I'll be multiplying both of these. This is the 0 0, x1 and x2 values 0 0, and the weights are also given, first weight and second weight 1 1. I'll multiply them both equally. I'll get an answer here. This answer is less than 1. So what should be my output? My output will be 0. What is my expected output? Expected output is also 0. Done. 0 1. 0 1 means 0 multiplied by the weight corresponding 1, and 1 multiplied by weight corresponding 1. Add it up, you'll get the answer as 1. 1 is greater than or equal to 1? Yes, it is. So my final output is 1, and my expected output is 0 in this case. I'm getting a mismatch here. For 0 1 I should get the expected output as 0 only, but I'm getting it as 1, right? So see here, for 0 1 I should get the output as 0, but I'm getting the answer 1. So in this case I have to update the weights. Okay, for that what I'll do is I'll be applying this formula for w11 and w21. I'll be multiplying w1, the initial weight which I had taken as 1 and 1, that I will be adding it with the learning rate 1.5 I have taken in this case, target minus the output value we check out. My target was I should get as 0, but I'm getting it as 1. So 0 minus 1, 0 minus 1. Xi, my input for the first one was 0, and my input for the second one was 1, 0 1. 0 1 is this only. What are the inputs I'm giving? Okay, so I'll multiply and I'll get some answers here. 1 and minus 0.5. 1 and minus 0.5 is nothing but the updated weight values. Updated weight values, when I get what I told you, I have to again start from the beginning and check each of these test cases. This test case has passed for the previous weight values. Now because of this I got new weight values. I have to again check these from the starting if it satisfies for the new weight values or not. That's all what I'll be doing here also, and what I get to know is it will be satisfying. Let's quickly run through it how it satisfies. See here, 0 0 is given here. You just multiply this by the new weights 1 and minus 0.5. You'll get the answer which is expected. Same answer, same goes for this one. Multiply and get the answer. It is minus 0.5 less than 1, so expected output is 0, and here also the output you will get as 0, because whenever the output which you get less than 1 means output will be 0, so it will be according to the expectation, so it's correct. Same thing goes for this one and this one also. When you have passed all the test cases, which is the final weights, that is your answer, 1 and minus 0.5. So your final answer will be 1 and minus 0.5. Keep that in your mind in a side place. Now come back to the second one. Next function also will do the same thing. I will be writing the truth table here. You can go to this for more information. I will not explain each step one by one. Same thing you'll be doing. You'll be getting here also two weight values, which are the winner weight values. So what you'll be doing here, 0 minus 0.5 and 1. Here the winners are minus 0.5 and 1. In the previous one it was 1 and minus 0.5, right? So these are the two winner values you are getting. After you have got the two winner values, what we have to do is we have to keep it aside in our mind. Okay, for now we have to consider the last one. We have done with the function 1 and function 2. The function 3 was this one, z1 or z2. So we are concerned with this one. In z1 and z2, observe carefully what's happening. Whenever I was in x1 and x2 and going to z1 and z2, in between I had some weight values. In the same way, whenever I am in z1, I have to get to y. In between I'll have some weights. Let's take it as v1 and v2 for z1 and z2 respectively. After I have done that, what will be my y equation? Y will be equal to the summation of z1 v1 plus z2 v2, just as how we did for this one. Z1 was what? X1 this w value multiplied plus x2 with this value multiplied, that's summation. Same thing here also, what I'll be doing, z1 with this value multiplied plus z2 with this value multiplied, that will be my y value. Like that I'll be making the truth table here. When it is 0 0 0 1 1 0 and 1 1, the corresponding z values which I was writing in the previous cases for z1 and z2, means what table I'm referring is this tables. Z2 values were given here, this I'll copy paste there, and z1 values also I'll copy paste in the same way. Z2 z1 values, this also I'll copy paste. When I have done when I have done that both, at that time what I'll be writing is the final y value. How I'm getting the final y value? In the final y value, what I'm expecting that 0 1 1 0 should be there. How I'm expecting that? When it is same XOR, what it should give? 0 output. So that's all what I've written here. Rest of the things should give 1. Okay, now I'm just concerned with this part of the table. By using these two values and choosing some weight, like for example here v1 and v2 weight are there, I'll multiply this z1 value and z2 value with the corresponding weights. I'll find out the answer. If it is less than threshold, my output will be 0. If it is more than threshold, my output will be 1. I'll be checking each time if I'm getting the correct one or not. If I'm getting the correct one, I'll be moving on with the second value, third value, fourth value. When I have done all the values and it passed all the test cases, what are the weight values that I'll keep assigned in my mind? That is the winner weight values. So exactly the same thing we are doing here. You can go through it. If you consider the v1 and v2 values as 1 and run through all the test cases, you'll get the final answer as the correct expected values. So finally, what are the weights? That's your final answer. What will be your weights of this one? 1 and minus 0.5. This we had got here, right? In the first iteration when we did, At that time we got the winner weight values for the first one, which is 1 and minus 0.5, and similarly for the second one when we did, we got the values as minus 0.5 and 1, and for the z, what the winners we got, v1 and v2 as 1 only. So all the winners you will be writing here, giving them medals and kicking them go to home and sleep. Okay, that's how you do for the XOR and the OR and the AND operations, and that's all about the perceptron. From here starts the main heart of the module's part 2. Here what we have is the gradient descent and the backpropagation. It's a very complicated and complex topic. Here I have mentioned all the aspects of what the backpropagation consists of, but for the exam point of view we just need to remember the algorithm, like what happens first and what happens next and what happens next. Inside that many numericals are there, many formulas are there, you need not remember all of those. Okay, so listen carefully to whatever I tell. First you need to know what is gradient descent and the delta rule. By using this one only you will be solving the backpropagation. What is gradient descent? Descent means what? If you are on the top of a mountain, you are coming down of the mountain, that is descending. Gradient means what? Slowly you are coming down. If you come fast you will fall down like a snowball and you will die, right? So gradient descent means slowly you will be coming down and you will be reaching a point, and if you find that it is a peak, again you will be moving further and again you will be coming down till you reach your home, right? That is what is called gradient descent. For that we will be using a delta rule. What is a delta rule? Used for non-linearly separable data. I just showed you what is non-linearly separable data. Linearly separable means from one line you can separate all the one plus together and the minus together. But non-linear means by one line, if you draw anywhere like this, it's not separating all the plus to one side, all the minus to one side, right? That is non-linearly separable data. For the data which is non-linearly separable, we'll be using the delta rule, and we'll be using the perception training rule, which we just studied in the previous topic. Okay, this is just for the linearly separable. Delta rule is for the non-linearly separable. You got the difference. Then we'll be seeing more about the gradient descent. Okay, main idea of the delta rule is to use the gradient descent to find out the best weight. Okay, for example, in the different nodes when we had, in that if we alter the weights we are getting the different outputs, right? Which is the best value so that we get the expected output. That best value who will find gradient descent in the case of what? Non-linearly separable data. Okay, so if this is the winner, okay, this is the winner, it is the minimum weight. At that time you are starting from here, you will come down slowly, you'll come down slowly. When you come down you get a point here. When you move further your cost increases. When you move further your cost increases. You will not move further, you will stay there itself, and that is the minimum error, and this is your winning point. Like that, gradient descent also will be coming down, going up, and comparing if the cost is increasing or decreasing. Based on that it finds the optimal point. Okay, so how to modify weights? Again the same formula, wi is equal to wi plus the delta wi. Each time it is not the correct weight, we'll be adding a delta value. Now what is the delta value? That is changed here. Before it was n into t minus o into xi, right? But here it is gradient descent value e of w. Okay, so let's have a look at what it is. It is the derivative of the error with respect to the weights. Derivative of what? Error with respect to what? Weights. Derivative of error with respect to weight is also called as gradient. Okay, so you need to know the derivation very well. The gradient of E with respect to W is nothing but error of W naught, error of W1, error of W2 till Wn. All these errors combined, that is called as error of W, right? So that's what we'll be seeing. The first one, delta E by delta W. In the delta E by delta W, we will be writing what is E. E, we know the formula, which is half into, for all the d values, td minus od whole square. This is the formula to find the error. Okay, this is fixed one. So when we differentiate it, we'll get the final answer. Okay, so we'll be now differentiating this value. How do we differentiate this value? When we differentiate this value, you remember, right, when we differentiated the values of x square, what is the differentiation of dy dx of x square? It is nothing but 2x, right? This 2 will come here and it will become minus 1 here, right? So it is 1 only. So that's what we'll be doing here also. When we differentiate this term here, the 2 will be coming here, and this term will be writing here, and again differentiating this term, and you again differentiate this term. You'll be doing it further in the further steps. For now, the 2 will be cancelled here, and this will be remaining as such here. And when we differentiate this one, we'll be doing one what? Substitution. What is OD? OD is nothing but, if you remember, it is the summation of wi xi, w1 w means w naught plus w1 x1 w2 x2 till wn xn. All this summation is what? This one, OD. So we'll be writing, instead of OD we'll be writing wd xd. Okay, for all the d values. So again we'll be differentiating this with respect to the w value. When you differentiate it, this is the constant, will become 0. when you differentiate w with respect to the w and some constant, that constant will remain. So it will be 0 minus wd will come off, it will be minus xd. Okay, 0 minus is nothing but minus xd, so it will remain here. This came from here. So this is what you'll be substituting in the place of delta ew. Okay, so in the place of, in this formula, in the delta ew, you'll substitute this point here, so it will look like this. Okay, so this minus minus will come out of here and this will be cut off. It will be n into this summation part, and this summation part is nothing but td minus od. Okay, that td minus od will be writing it as such here, and xd also we got from here only, the same thing. And this is the formula which will be obtaining at the last. So this is the formula for the derivation of gradient descent. Okay, make sure you know and practice this very well. A very important question from exam point of view. Visualizing the hypothesis space. This is the ew value, and this is the w1 and w2 weights. Okay, in the 3D vector if we see, it looks like this, and this is the minimum point which we have to reach, but we are somewhere here. So what we'll do, we'll move like this, again go there, again go there, again like this. We'll keep on going and until we reach the minimum point. That is what the visualizing hypothesis space is. We will be keep on doing the iterations until we reach the global minimum value. Global minimum means in all this space, what is the most minimum value, that is called as global minimum value. Okay. Then we have the gradient descent algorithm. For the same thing which we did above, there is a simple algorithm for that. We have training examples and the learning rate. Okay, and each of the training example is in the form of x and arrow. I don't know what it is called, x arrow and t. Okay, so x vector and t, while the this is the vector of input values and t is a target value. We have some input values, we need to get the target value, and the learning rate is given. These are the three parameters. Initialize each wi to some small random value. Just take the initial weights as some random value. Until the termination condition is not met, do the following. Okay, so what is the termination condition? I have reached the target value. Okay, initialize each delta w to 0. Initially delta w will be equal to 0. When we don't get the correct answer, then we will be updating it, right? So whenever we compute the values of o and we don't get the correct value, then we will be updating it, adding the delta w value. What is the delta w value? We'll be computing it here. Like that we'll do until we reach the final answer. That is what the gradient descent is. Some of the disadvantages are converging to local minimum can sometimes be quite slow. If there are multiple local minima, there is no guarantee that we can reach the global minimum for sure. Okay, these are the two disadvantages of gradient descent. To make it more nicer, what we'll be using is stochastic approximation. In this we'll be adding some values for updating the weight incrementally. Okay, so this is the formula for the stochastic descent, and we'll be using this formula for adding the weight values. Okay, means making the errors more lesser. So that's what about the stochastic gradient. If you ask me about the differences between both of those, in the standard gradient the error is the summation of all the examples before updating weights, whereas in stochastic gradient the weights are updated upon examining each training example. Here all will be done, here after examining it will be done. Basically it's that. The second one is summing over multiple examples in standard gradient descent requires more computation, and in the stochastic gradient, since it's a nicer algorithm, it requires lesser computation. Okay. Next we come to the last topic of this module, which is the multilayer networks and the backpropagation algorithm. Few theory concepts are there and the main algorithm of this one is there. You have to know that very well. Okay, so this is a super important question from exam point of view. What is multi-layer network? By the name itself you can understand, multi-layer means there will be many hidden layer, that's all. Okay, and each hidden layer is called as h1 h2. The output layers are o1 and o2. This is the input layers i1 i2 and i3. Okay, so the difference between single and multiple layer is there are multiple hidden layers in the latter. Okay, backward propagation of error. Okay, backward propagation of error is nothing but the backpropagation algorithm. How do we do the backpropagation algorithm? Let me tell you initially here. What we'll be doing is we'll be applying some formulas. X1, X2, X3 we have W1, W2, W3, W4, W5, W6. We'll be multiplying this one and finding out the answers. We'll be passing this here, and we'll be finding out some answers here. We'll be passing it here. There are some very complex formulas for that. Finally, when we reach the output, we'll check if I get the correct output or not. If I don't get the correct output, again we'll backpropagate. From here, how many backpropagation will be done? One to here, one to here, because from there only I came like this, right? So I should go back here and here. Here also I'll go from here and here. And at this point of time, what I will do, I got the two inputs, one from here, one from here. So both I'll consider, and again I'll go back. Like that I'll keep on adding the formulas, going back, updating each weight value. Again I'll come back and see if I get the correct answer. If I don't, again go back and come back and see. And until I reach the correct output, means the conclusion, what I get output that matches the target output, I'll be doing this same thing. That is what backpropagation algorithm is about. The first thing moving forward, second thing is going backward, and last thing is checking again. Okay, those are the three methods which I have divided into. The first one is calculate the forward propagation error. Okay, so in this I'll be briefly going you through the formulas and giving you the brief idea of what's happening here. You need not memorize the formula, you need not memorize the actual values, you need to understand what's happening. Okay, so let's see what's happening here. The first step is calculate h1 in and out. For in and out both you have to calculate what h1. What is h1? First let's understand this diagram. In this diagram we have x1 x2 and h1 h2 and o1 o2. Let's understand what it is. x1 x2 are the input values, and w1s means this whatever the w's you can see in between are the weight values for the corresponding edges, and o1 and o2 are the corresponding target nodes. First I have to get here 0.01 from this node when I do the calculations here, and from here when I reach I should get the output as 0.99. Then my weight values what I've set here is correct. Okay, initially it's a random values all weight. Okay, and in between I have hidden layers also, and I am using a bias values also 0.35 and 0.60. What is bias value, how does it affect, that will be learning in the next module. Okay, for now just keep in mind the bias value is also a factor we have to consider. B1 will be considered when we are doing calculations with respect to this layer. B2 will be considered when we are doing calculations with respect to this layer. So I hope so the brief overview or the map of this backpropagation is clear for you. Now let's have a look at the calculation part. What is h1 in? H1 in means from where all h1 is coming in. From x1 it is coming and from x2 it is coming, right? So those two will be considering x1 w1 plus x2 w2 plus b1. B1 why? Because this is the bias layer. I told you we have to consider this value as well. Just substitute those values, find out the answer. This is the value for h1 in. Next, after we get h1 in, we have to calculate h1 out. By getting h1 in, we can easily calculate h1 out by substituting h1 in this formula. So when you get this answer, keep it as such in your side part of the brain. Do the same thing for h2. For h2, where all it is coming from x1 and x2, and these weight values also given. Use these weight values, add the bias value of b1 here. You'll get the value of h2 here. Then calculate the h2s out also in the same way. I have not written the formula. The answer just directly I have written here. So you'll be getting h1 in and out, h2 in and out. After you got h1 in and out, h2 in and out, your next step is to move further in the layer. Now you have to go to O1 and O2. How do you go to O1 and O2? For that also some formulas are there. We have to calculate O1 in and O1 out, O2 in, O2 out. This is the formula for O1 in and for O1 out. Once you get the O1 in, substitute that in this formula to get O1 out. Same thing goes for O2 in and O2 out. First calculate the O2 in, substitute this in this formula and get the O2 out form value. After I've got the O1 in and O2 out, what does that mean? This means that we have got an answer here and here. Our next step is to compare this one with this one and this one with this one, whether it is same or not. Let's have a look whether we get the same answer or not. Obviously in the first step we don't get the same answer. What answer we got is 0.7513. Let's write it in a separate place here. In the separate place, when I write and calculate the total output, means what is the error I am getting. See here, 0.01 was my expected at the O1, but I got 0.7513. That is a different value. Here also 0.99 was expected, but I got 0.7729. Here also it's not the expected value. When I don't get the expected value, I have to calculate what is the overall error happening. So this is how you will calculate error. E total is equal to summation of half. Summation means for O1 one error will be there, O2 error will be there. Just add it out, add them both. Target minus output. What is the error? Square it and do it half. Again add it by the second error and tell me the final answer. The final answer will be 0.29. This is the approximate error which we are getting. Okay. So now to reduce this error, what we'll do, we'll again backpropagate. That is the second part. Okay. So second part is calculation of the backpropagation error. In backpropagation, we'll be doing it in two steps: output layer to hidden layer, then hidden layer to the input layer. Okay, that is the third part. This is the third part. This is the second part. For each of these, there is a different formula. Okay. So see here, what I mean is, this is the first part what we did. We reached like this, got some output. Second, we'll in the second part we'll go from output layer to hidden layer. This is the second part. Third part is from the hidden layer to the input layer. Okay, that those are the three parts for the backpropagation. Like this it will happen 100 or 1000 times. Okay, that in computer it will happen very fast. So we just need to know the algorithms working. Okay, so I hope so the things are clear till now. If not, just rewatch and wind this video, rewind and watch this video again. Why? Because if you did not get till now what I told, there's no point in continuing this video. You can exit this video. Okay. See here, you have to go from output layer to hidden layer. In output layer, how many W's are there? W5, W6, W7, W8, right? See here, W5, W6, W7, W8. Those are what we are considering. If I zoom in here, W5 is here, and W6, W7, and W8. These weights we are concerned with right now. So you have to alter these weights. Why? Because I got the wrong answer. Why I got the wrong answer at this place? Because of this weight. Why I got the wrong answer at this point? Because of this weight. So first we have to alter this one, then this one. Okay. So to alter this one, there are some formulas. I'll briefly go through it. You need not worry much about these formulas. This is the formula for W5. First we'll alter W5. We'll have to calculate E total. This is the formulas. You have to find out each of these terms. It is given here. If you are if you want to know what are these terms, you can go through it, but it's not necessary for the exam point of view. You'll be doing the substitution parts here, and you'll be finding out the answer for W5. For W5, the new value which you get, substitute back. Do the same thing for the W6, W7, W8. After you're done for all of those, move to the previous part, like from hidden to input layer. In that we have W1, W2, W3, W4. Same here, also some formulas are there, different formulas. You have to substitute those values. A very complicated procedure. After you've done all of this, finally what you get the final answer for W1. Like that you have to do for W2, W3, W4. This will not be asked in exam, just for your information. You have to explain, we'll be doing these things, and these things. Okay, that will you have to explain. And after we have done that, we have got the new weight values. Again repeat the backpropagation algorithm. Now we have new weight values, right? What we'll be doing with the new weight values? We'll be replacing the old weight values with the new weight values. After you have done that, again we'll start from here. We'll calculate these values, and again from here we'll calculate these values in the first part what we did. And again one answer we'll get, we'll compare it with this one, if it is same or not. If it is not same, then again we'll come back and edit the values. Here also two aspects are there. If I get more error than the previous one, I'll remove this one, right? If I get the more error, like for example in the first iteration I got the errors as 0.29, right? Here I had mentioned what the error I've got, 0.29. Now if after editing the values I got the error as 0.3, there is no point in the new weight values. I'll discard it and again do the same thing with the previous weight values. Again I'll try if I'm getting the more accurate answer. If not, again I'll do the same thing until I get the most accurate value. This is what happens, the whole thing about the backpropagation algorithm. These are the practical aspects of this algorithm. Now let's have a look at the theoretical parts. Okay, so I hope so you can explain this in your own words. If you understood it very well, easily you can explain it, right? So here some of the things which you consider in the algorithm is training example, learning rate, h1 in, h1 out, and something I have written, I only don't know what it is, sorry. So anyways, it does not matter. Some things what we consider, that only we have to write here. Okay, after that we'll be seeing each training example we'll consider. See, in each case we'll be considering each training example. We'll be setting the learning rate here. Okay, just briefly go through it. Okay, we'll be setting the a learning rate and the hidden layer, so it's n hidden. Okay, so now I got no, this is n hidden. Okay, this is n in, n out, and this is n hidden. Okay, so we'll be considering all of those terms which are necessary for calculation of this algorithm, and then we'll be starting the algorithm. Create a feed forward network. First we'll be doing the first forward propagation with the inputs and the hidden layers and the output values. Initialize all the weights to some random values. After that, when we get the final answer in the O1 and O2, then check if it is equal to the targeted output. If it is equal, then you can end the algorithm. If it is not equal, what we have to do is we have to update these values using some formulas given here. After you have done that, we'll be updating each of these weight again, and again we'll be repeating the same procedure. Okay, so write one or two times, you'll get to know what are the algorithm mentioned here. Anyways, even if you don't write it, you'll be getting you can write this in your own words only, right? If you understood what's happening here, you can easily write it in your own words only. Okay, and the formulas just you have to keep in mind. Okay, that's all what's about the backpropagation algorithm. We discuss how it works and all. Now we have to discuss what is the derivation part of it. Okay, this is very important from exam point of view. To derive the equation for updating the weights in backpropagation algorithm, we use stochastic gradient descent rule. Explicit question from exam point of view. Okay, don't miss this one. Stochastic gradient, we use stochastic gradient that involves iterating through the training examples one at a time. For each training example, a descending gradient descent of error ed with respect to the single example. We'll be calculating ed in each cases. Okay, so few lines of examples are there with two test cases. We have to write the two test cases for compulsory if you expect full marks. Okay, so let's get started with the algorithm, and I mean the derivation. So each time we have to find out the delta wij value and update the previous wij value. Okay, so this is the formula which we'll be using. W delta wij is equal to minus n into ed by wji. Okay, so this is one of the formula given for ed, which we'll be using in this case, and some notations are given. You can go through it. I'll be just explaining what is happening here. Sorry for the bad diagram, but I'll be explaining you briefly what's happening. X1, X2, X3 are the input values, and this is nothing but, see, if you get to know what I've written here, you can easily get to know what I've written in the rest of the things also. 1 and 4, you can see an edge, right? What I've written is X I've written because X is here, W I've written because the weight has, means the edge has some weight, okay? And how do I write the numbers? From where I'm going to, from where I'm coming, okay, like that. Out in, just remember out in. 4 1, 4 is the out, and from 1 I came, so 4 1, W 4 1, like that. To where you are going, from where you came, out in. Okay, 4 1, X 4 1, W 4 1. So let's take up some random value, this one with this one. 2 5, so what I'll write, X 5 2, from 2 to 2, and from 5 to 2, from 2 to 5. Okay, so that's why out in, W out in. So this edge will contain this one. Okay, that's what I've written, x52 and w52, like that. For all of these we'll be writing. Okay, that's all. This diagram, I hope so you draw it in your mind. So the important concept starts from here. So first what you have to write is, you have to notice something here, that the weight value can influence the rest of the network. What is the weight value? The weight value is W41 in this case, W51, W42, W52, W43, W53. The weight values only here it are used. Here it is different weight values. So altering the weight values will alter all the influences that happen here. Understand very briefly. Don't go into details. You'll get confused. Okay. So since the weight value can influence the entire network, I can write this one ed by wij as ed by net j and net j by wji. If you cancel these both, again you'll get the same thing, ed by wji. So net j, what I'm writing, net j is nothing but the summation of all the weight values. Summation of all the weight values. This is affecting the rest of the algorithm. That's why we are differentiating this with respect to this, then with this with respect to this. Okay. So the weights W41, W42, W43, 51, 52, 53 are just used once in the algorithm and not anywhere else. Net j is nothing but wj into x ji, means the weights multiplied with respect to the x values, the input values. That whole summation is net j, and the net j with respect to the wj, if I just take it in the denominator, I'll remain with this one. So that's what I've written here, net j by wij in the denominator, xji will be remaining. So in this place, wherever I encounter this term, I can write it instead of xji, right? So that's what I've done here. This term I'm encountering here, so in this case I'll write just xji. So what I'll get, ed by wj, ed by net j xgi, ed by net j into xgi. That's the same thing I've written here, ed by net j into xgi. After I've done this one, then I have to consider the main formula. The main formula is delta wgi is equal to minus n ed by wgi. This is the main formula, ed by wgi. Just now we found out what is ed by wgi. This thing will substitute ed by net gi into xgi. Okay, after I've done that one, that much, I have to calculate what is the value of this one. To calculate value of this one, listen carefully. First what we'll be doing is, we'll be considering the two cases, one for the input, this for the output and this for the internal unit. First we'll consider for the output unit, and for the internal unit, two answers you will get. Finally, after present those two answers, that's all the derivation for the backpropagation is. So the first one, what is the first one? Output unit. For that, first what you have to do, you can observe that means the backpropagation algorithm is influenced through the OJ. OJ means the output value. What I mean is, see here in these hidden layers, what is the output I am getting? This is the output, this is the output, this is the output, and this is the output. The output is the input for the next layer. So this output is influencing the answer in this layer. So output is what? An influencer. Okay. So by using that concept, what I will be doing is, I'll be writing this same term, which is ed by net j as ed by output j into net j divided by net j. Okay, if I cancel this one, I will get the same thing. Just have to practice this and write, no other option. Okay, you have to do the same things what I've written here, just practice it and write. Okay, now our main question is, what is the value of this one? This one is nothing but the ed by oj, that has a standard formula. Ed can be written as this one that I've already mentioned, right? Ed can be written as this one, where I have mentioned, just going through the back here. Yeah, this I had written, right? We'll be considering this formula, this same formula we are applying. ED's formula, whatever I've written here, that same formula I'm applying here. Okay, just considering the delta part outside. This is the delta part which I consider outside, and the rest of the thing I've written inside. Okay, e's value, instead of e I've written this one. Now what I will do, I'll be differentiating it with respect to oj. I'll differentiate this one. Okay, do that time the same thing, square is here, so square will come here and 2 will get cancelled. This I'll write the same thing again. I'll differentiate this one. When I differentiate this one, this will become 0 and this will become -1. So this will be cut off and -1 will be there, so this will be cut off also, and minus will be outside, so minus tj oj. That's I've written here, minus tj and oj. Okay, so this one value I got, this was for which value? This was for this value. Same way I'll calculate oj by net j also. Oj by net j also, this is the standard formula, oj by net j. So oj by net j, this is a standard formula like this. So by standard formula, this I have to by heart and write, and this is the value which I get, oj 1 minus oj. I'll substitute both of these 1 and 2 in the equation initially which I have written. In this equation, if I substitute this answer which I just got, these both answers, what I'll get is, I'll get this one. Okay, I'll get this one. Now we have to consider the main formula. Why we are doing this one? To substitute in this place, right? So wij is equal to minus n, this one. So instead of this one, I'll substitute this thing, but it's not actually just this one. This one was previously substituted for this one, right? Ed by net j into xji. Where this substitution happened, if you remember, this we are done here. This substitution, right? From where this came, by this one. This I can write as this one, and the substitution was made it accordingly. Right, that substitution was made here, and using the same formula here also, and just substituting. Okay, so after I've written this one, I found out this value. This is the same value which I'll be substituting in this current place. In this circle, I'll substitute this underlined thing. When I do that, I'll get this answer, and xj will remain as same from the previous one, and this thing I'll consider as delta j. Okay, delta j I'll consider and write it as a small sweet formula. Okay, that was for one of the answers. If you write this one, you'll get 50% marks. How many marks? 50% marks for the backpropagation algorithm. Second, if you write one more page, you'll get full marks. Okay, till here if you write, you'll get full marks. So let's see how what it is. In this one again, you'll consider the same thing here. If you're doing it for the hidden unit or the input layer, then at that time you'll have to write this formula. Okay, very simple formula. Just write a summation here, and k in all downstreams of j. Downstream of j means what? If you want the in detailed explanation, downstream means what? If I'm considering this one, downstream is this one. For this one, this is the downstream. For this one, this is the downstream. Okay, so for each k, I'll be taking these two values. For this one also, I'll take these two values. Okay, that's all what I'm doing here. For each downstream, listen carefully what's happening here. Ed net j, ed by net k by net j. If I write it like this, this both will cut, and this will remain. Why I'm taking k? K is because this is k value, this is j value. Okay, k is dependent upon j, that's why I'm taking this as k here. Okay, so this value, okay, this value I can substitute it as minus delta k. How is that happening? This values, if I just make it expanded, at that time what I get is this one. This one is written as in this way, ed by net j. See, ed by net j, from where I'm taking, from the previous one I'm taking ed by net j. How I'm writing it here, in the same way I'll be writing it for k also. This is the letter difference is there. If it is j, I'm writing here all j's. If it is k, obviously I'll be writing all k's here, right? That's what I'm doing here. The j is given here, so I've written it as j. So if it is k, I'll be writing it as k. So in that case, what it will become, this whole thing will become delta k, right? That's what I've written here, delta k. Minus is because this minus was present here, in the formula also it is present, if you see. So that's all. This substitution was made for this one, and we are concerned with this one. Now how to do that substitution? This substitution is made based on this one. The net j will be splitted here by using chain rule. Net k by oj, oj by net j, because k is dependent upon the output of j. That's why I'm writing in this way. Okay, so this one, this particular thing, that I can write it as wkj. How I can write it as wkj? See here, net kj by oj, net k by oj, this I have written here. That formula's expansion is net k is nothing but x into wkj. Okay, this is the standard formula. Oj is same as previous one, and the xk is equal to oj. Okay, the input is equal to the output in this case. So that's why I can substitute this in this place and just cut it off. So what I remain with, wkj. Okay, this all things you have to by heart, and nothing is making sense to me also. Okay, if you want marks, just by heart and write in the exam and come back. So you'll be writing this as same as the previous one, and after you have got this one, then what you'll be doing this is doing the substitution for this one. In this substitution part, there is a standard formula for this one. Because of this, you'll be writing it here, and there is a standard formula this also, and this simplification is this one. Okay, so basically you'll be doing the substitution part here, and what answer you get is this is the final answer, the fourth one. Okay, for which you got this answer, the fourth one, for this value. Okay, this value got this answer. So wherever this is there, I can substitute the 4 in that. 4 means this thing. Okay, so where I have that, in this formula I have that. For this only I'm finding out, right? This only I found out earlier. So I can substitute 4 in this place. If I substitute 4 in this place, I get this answer. Xj is here, xj is here, n is here, n is here. Minus came from this formula only. Okay, so after that, I'll be taking this whole thing as delta j, and I'll be writing it here. Okay, this is all what I have to do in the backpropagation algorithm. Practice is nothing, means practice is the only thing which you can do here. There is no other go in which you can just directly see and by heart. Okay, if you want marks, spend some time. It's a super important question, don't miss this one. Okay, let's move on some theory questions that they didn't end this video. So what is the effect of momentum? This is also question paper question. Effect of adding momentum in backpropagation. Momentum is what? See, if you're driving a truck, okay, and you hit one person, okay, if you're driving a truck and you hit one person and the truck stops, the person will go as far as the truck was moving in that speed, right? So that is because of momentum. If the same truck comes and hits him at 1 meter per second, nothing will happen to him. Why? Because momentum was less. Momentum is nothing but mass into velocity, right? Remember, velocity is the important concept. So adding the momentum in backpropagation is nothing but applying a separate formula. Okay, these are thing which will be adding. This is momentum, this is the initial value. Adding a momentum will make it more better. Okay, like if I give you the actual thing, what is happening in the backpropagation is, if I have a mountain here, okay, you're finding out which is the most deep point. Okay, so once you get a deep point, if you are satisfied, you will tell that I am satisfied, I got the deep point. But that's not the global deep point. If you consider this whole picture, this is the most deep point. So if you add momentum, what will happen? This will not stop here. By the speed, it will go again like this, again it will come, again it will go, and it will check all the possible deep points. In that case, you'll get the most deep point. That's the actual thing why we are adding momentum in backpropagation. Okay, so that's one of the important questions, and the formulas and the answer is given here. You can go through it. Next, what is the remarks of backpropagation? This is the last question. Convergence and the local minima. Convergence means what? Many nodes are there. Okay, many nodes are there, each are interconnected, information will be transmitted, and all will converge to one point. That is known as convergence. Local minima means there is many chance in backpropagation algorithm that you will be satisfied with local minima. Okay, it's not always that we'll get the global minima, it can be missed also. Okay, that's the first point. Second is representational power of feed forward networks. How efficiently you represent. The wider the deeper, that matters. Okay, the wider and the deeper network is, that matters. Okay, three functions are there to represent: boolean functions, continuous functions, arbitrary functions. By using these three, you can make it more efficient. Hypothesis space search means all the possible combinations, that is hypothesis space. Inductive bias means there's a difficulty in to characterize precisely the inductive bias because of backpropagation. That is because it depends on the interplay between gradient descent and the way in which the space search of representational functions. Because of these two reasons, gradient space and representable functions, because of these two, inductive bias is not possible. That's the third point. Hidden layer representation. This is an interesting concept. If there is two layers here, input and output layer, and in between what happens is, because of these interconnections, there is a hidden layer formed in between. Okay, that is called as hidden layer representation. And the last one is generalization, overfitting, and stopping criterion. So what happens is, here I'll give you an example. Generalization means what? Suppose that this is one of the data given to us, okay, and there are some noise points like this, okay. So if you just observe carefully, if I tell you draw a line which matches most of the data, you will draw a line like this. But if you train it more and more on just this data, what happens is it will train it like this, exactly how it is, okay. So what will happen is, when it trained like this, in the upcoming topics also it will just train it like this only, and will get not a straight line but some different values. Here so much error is there, here so much error is there, here so much error. Why? Because I trained it very precisely in the training data. I did not generalize what's happening here. That is called as overfitting. After an optimal amount of time, you have to stop the training. That's what you'll get the most optimal solution. That's all for this video. Make sure you hit the like button, subscribe to my channel for more videos like this, and thank you so much for watching. I'll see you in the next one.